genomes are 97 to 98% the same. You get arguments. Some people say it's 2% different. Some people say it's 3% different. I go with 3%. Let's just say 97% the same genome chimps have and we have. 3% difference. There is no way that a chimp and a human can make an offspring. So that we know that if this is happening, that has to fall within that 3%. We have always assumed that the Starchild, when its genome was recovered, we had hoped that it would fall closer to 3% than to the 99.9% that all of us are. We're all 99.9% the same. You get some arguments and people are trying to say, well, maybe it's 99.8, 99.7, but you hear most consistently 99.9. We're almost clones. We're so alike. That little bit makes all the difference in all of us, right? But if you look at 3% makes us, the difference between us and chimps, that sort of makes sense, doesn't it? Because there's a lot of difference between us and chimps. And gorillas are 95%. 5% difference, 95% the same. Rats are 70% the same. And a lot of animals are the same. It's all blended in together. The same material is used over and over again in various species. Lots of different species. So for this, it's got to fall within 3%. We're hoping it's falling closer to the chimp because if it falls real close to the humans, what are the scientists going to say? It's just a variation. It's just a freak. But if it's over near a chimp, it's pretty hard to make that argument, right? So we always felt that if it came in closer to 3, we would win. If it came in closer to 99.9, they would win. All right? So I say to him, given what you have, where do you think the difference is going to be if we're talking procreation? He says, oh no, we're not talking procreation. The difference is going to be between 10 and 50%. Between 10 and 50%. Now that's a big margin because he only has a little bit. But he says if you just extrapolate it out, that's where it's going to fall. Probably in the range 15, 20, 25. So very different that it's not even a question that it's an alien. In fact, it may be all alien except for the mother. Now I know what that sounds like. We're just speculating now. I know. She's saying, what? I was the same way. What? You know, but this is where it is. This is going to blow you away, but this is where we are right now. Subject to change. Subject to the loaf of bread. But this is what we're looking at with the small part that we have, the slice that we have right now. Human and chimp genomes. Just so that you know the difference. This is a little sidetrack, but it's very interesting. Human and chimp share everything the same pretty much, but there are some significant differences. The main one being that all higher primates, chimps, gorillas, right on down, have 48 chromosomes. 48 chromosomes, 24 from each parent. We are the only higher primate with 46. Where did those 2 chromosomes go? And if that's a lot of DNA. And if those 2 chromosomes went, how do we still share 97% of the same genome and 95% of the same genome with gorillas? How do we do that? Well, the truth of it is, the 2 chromosomes that we're missing are not missing. They have been altered. You'll notice that the 2nd and 3rd primate chromosome in a human has been fused. Somebody has neatly clipped off the telomeres and fused it back together, those 2 ends together, such that they continue to function. And genes are sensitive things. You have to know just what you're doing to make it work right. And to do that is really an amazing thing. And guess what? Nature can do anything. Nature can do anything. That's what they tell you. I'm telling you. You confront them with this, they say nature did it. Nature can do anything. We can show you other examples of that, and sure, nature can do that. It's only done in domesticated plants and animals where you see weird things happen in the genomes because they were genetically engineered. That's the truth of it. With humans, guess what? Some of these other, 9 of these other chromosomes, segments have been taken out, taken out, flipped in on in, and put back in, and, and glued back. Boy, I really did a lot. And glued and put back in. Taken out, flipped over, and put back in. 9 other ones. And on top of that, if everything evolved the way they say it did, we should have everything somewhere behind us, right? Of our 25 or 30,000 genes, we have 232 genes not found in any other species anywhere else on the planet. Where did they come from? You know what scientists say? Well, we must have been infected by some exotic bacteria that left their traces and then went away. Occam's razor. I have made fire. I have thought of a simple answer. You know, it's just ridiculous. So this is just to show you that this is my other work. This is the work I love, you can tell. The human origins, hominoid, stuff like that. This is what I really like. But I won't hit you with any more of that, because if you don't know about this, it's got to be a hammer shot for you. I know that. Okay, so we're talking about if we can't have a sexual offspring, it has to be in vitro. The Starchild then turns out to probably be in vitro. If it's that big a difference, it couldn't be anything else. And we're doing that now, and it's test tube babies. You know how it works. It isn't that hard, so it wouldn't be for a higher race of beings to do it 900 years ago, or 9,000 years ago for that matter, or 200,000 years ago when we were created. All right, so I said, well, okay, how would it happen? How could it possibly happen that you have something that's so heavily alien, and you can look, there's nothing hardly left of the human in the skull, it's dominantly alien, but how can you get something so heavily alien coming out of a human mother? And so he said, well, maybe it's a 3-parent birth. I said, what? 3-parent birth? What's that? Well, it sends me the slide. If a woman has what's called mitochondrial disease, that means her mitochondria are bad, and she has a child, that's a dead child. That's a horribly screwed up child. Now, if she wants to have more children and they know that she has mitochondrial disease and she and her partner want to have more children, well, what can they do? They can do this. It's incredible. They can take healthy nuclear DNA is removed from patient's egg cell, leaving behind faulty mitochondrial DNA. This is bad mitochondria. They take out her sex cells, her 23, remember in the sex cells you have only 23 chromosomes to match with the cells from the sperm who make the 46. So you take out her 23 chromosomes that she's going to add to the zygote package, and they take a good egg from a woman who does not have mitochondrial disease, and they put it in, they take her genetic material out, and they put hers in. So now she mixes with her partner's sperm, and they make a zygote in the healthy egg with the healthy mitochondrial DNA. And this child is going to be born in her, out of her, and it's going to have the DNA, the nuclear DNA of her husband rather, or her partner, and herself, and it's going to have the mitochondrial DNA of the 3rd parent. Is that not cool? Is that not cool? Yeah, I know, she's sitting there going, what? Yeah, it's goggle-eyed, isn't it? Yeah, I know, it's really, really cool. Now, with that in mind, how would an alien have been done like that? Well, what he said was you could have an alien couple. Why they would do this, and I'm not buying this entirely because it doesn't make sense to me, but why they would do it. But you could have an alien couple, make a zygote in vitro, take out the sex cells of a human, put it in, gestate it, and produce the star child out of a human mother. Now, it just makes no sense to me. Why would they do that? Why would they do that? Now, if they're like us, if they're a lot like us, which, the Greys, I don't know how much they're like us, but genetically, if everything's made out of those 4 nucleotides, they're probably a lot like us. And so that would explain the 10 to 50%. It begins to make sense, even though it's just still incredible. I'm having a hard time wrapping my mind around it, and I know all of you are too, but nonetheless, this is where things are leaning right now. So, We're down to this, folks. We're down to just simply needing the money. Show me the money. Remember the movie, Show Me the Money. And this is what it comes down to, and this is what I'm out on the road talking to you people, talking to people about it. This is what we need. This is what we need to do. We need to recover the loaf of bread. We need to recover the genome. We need, at the same time, we're planning to make 2 documentary films because there's 2 parts to the process. There's recovery of the loaf, which takes 3 to 4 months, and there is reading all of the ingredients in the loaf, which is another 8 to 12 months. So we're going to make 1 documentary film based on the recovery, which is going to tell us that difference within a range of about 5 points, 10 to 15%, or within a 5-point margin of error, a ballpark estimate. And then the final part, the 8 to 12, is going to narrow it down to about a 1% margin of error. We'll know exactly what it is and what the differences are. And more than that, we'll be able to then start the process of doing some bioengineering and adding to the storehouse of knowledge about human health, because there will be things that will come. Right now, as we sit here, they're trying to figure out what in the DNA of a Neanderthal is better than the 4,000 plus genetic defects we have. Did you know that? We have over 4,000 genetic defects, more than just about any other species. 4,000. And the Neanderthal is going to have spots in it where it is perfect, where we are bad, where we're wrong. And there may be a way to fix us using that. Well, the Starchild is going to be even better than that. And it can start right away with collagen, because we know a lot about collagen. And its collagen is so much denser and so much better than ours. What if we could find a way to just improve the bone solidity, the bone strength of 10 to 10% or 20% of everybody? No more osteoporosis. A wonderful thing. That's like within 5 years, maybe 10 at the most. And who knows what other else kind of things can come from this. So we're not just making history, we're going to improve the lot of every human being on Earth. If we can keep this stuff out of the hands of Monsanto and the big companies, that are going to be after it. And that's part of the challenge as well. To find somebody who will invest the money that we need, who has the same sort of attitude that we have about it. Not in it to make every buck possible, but in it to do the most good possible. That's my attitude, and that's the attitude I want to bring to the deal. But I'm telling you all, this investment is a very sound investment for whoever does it. It's a few $1,000,000. It isn't bad, really. It isn't bad for 2 documentary films. They will make 5 to 30 or more times their money back. And I've got, for anybody that knows anybody that they think might be interested in this, I can get you the documents that show what the deal is and what the percentages are and what the rate of investment is. This is Switzerland, and this is where money talks, BS walks, and small change rides the bus. So I know you guys must know some people who can do this. So if you do, please get in contact with me. I can get you information. I can give you information. I can give them information. Now, I'm going to close with a quick story after I show you. If you want to know more about it, this is the fully updated ebook, which is available on the Starchild Project. If you just want the overview kind of that I've given you and then some, and you want to show friends something that they'll read, you can read this in less than an hour, easy, anybody. It's just pictures and text box, pictures and 125 photos and illustrations and text boxes. Up to date though. This is the book, and this is only up to 207, but this is the backstory. This tells all the personalities, the people involved, the various scientists involved, the details of how the ups and the downs, the ups and the downs, the ups and the downs that this 12-year cycle has been. Now, let me close with the biggest probably down of all. When I got the word of this, it was late March when he said, "You've got it in the bag. You're going to make history, it's going to be a big deal, and we want to be involved. Start finding your money and getting it underway. We're ready to go."